Hello everyone, welcome to this video. In this video, we'll be continuing and giving you an example of a subgroup which is formed by a normal subgroup. Remember, I have showed you a procedure where we have used that in order to have new subgroups from the one which is normal subgroup of a given group. Now, let's consider the dihedral group D8. Now, what is the order of this group? The order of this group is of D8, that is, the order of Dn, that is 2n, right? So its order is 16. So here, this is basically the symmetry group of this polygon having 8 sides, right? Okay, so apart in the 16 elements, we have 8 elements which are reflections and 8 elements which are rotations, right? So what are those? Let's first quickly see that we can name the reflections as F1, F2, F3, F4, F5, F6, F7 and F8. What are these reflections? These reflections are obtained when, suppose, you are taking this axis. For this axis, if you take the mirror image of this polygon, you would get exactly the same figure. Hence, let's call that as F1. Similarly, we can take this axis, which is your horizontal axis. If you take the symmetry of this polygon with this axis, you would have another symmetry because you would get back the same figure. So all these 8 lines here tell you different, give you different reflections, which would give you back the same figure. And if you wanted to label them, then you would get different members here, right? So we can do that and see it very easily. So let's mark the reflections as F1, F2, F3, F4, F5, F6, F7 and F8. And in total we have 8 rotations, right? So in total we have 360-degree angle and we have 8 such rotations. So each rotation would be of an angle 45 degree. So therefore the rotations, they are the identity rotation, which is R0, then we have R45, R90, just keep adding on 45 degree to each of the angles. So next would be R135, R180, R225, R270 and R315. Right now, apart from these 16 members, let's consider a subgroup, a subset which forms a normal subgroup of it. And for the dihedral groups, we have a subgroup of which consists only of rotations. That subgroup is a normal subgroup is in Dn. We already saw this through an example in the previous video, right? So let's construct this edge by taking only the rotations which are R0, R90, R180 and R270. Now this is a normal subgroup, right? Now we will make use of this normal subgroup in order to construct another subgroup. Let's now consider another subgroup. Let's call it by the name K. Let us consider it has the identity element and any one of the reflections among this one, F1 to F8. So let me just write down F only in place of the reflection element here, because it could be anything from F1 to F8, right? So now we can make use of this normal subgroup and any of the subgroup of the given group D8 and construct new subgroup which is HK, where the elements, if you remember the definition, would be obtained in this manner: HK, where the smallest has been taken from the capital H, which is a normal subgroup, and small k has been taken from the capital K subgroup, right? So this is what we are doing here. We are taking R90, R180, R270 here, R0 as the first element here, and then we are taking both of them one by one. So R0, 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 and then F, F, F and F, right? So you can simplify the members here. So you would have R0 here, R90 here, R180, R270, then it would be F, then it would be, these three would be the same, right? So this is the new subgroup which is formed by taking a normal subgroup and any subgroup from the given group D8, and this is how you create new subgroups using this normal subgroup. So I hope you understood this example well. Well, that is it for this video. Thank you for watching.